Okay, some of you, you may not have time to complete the problem, and that's okay. I want to review as many things as is possible, so just try to go as quickly as you can. All right, so the first one, let's do 2a. 2a, which ends up being the cube root of negative 64. And I'll tell you what, let's also then do number 4, which is the square root of 121 a squared b to the 4th. Square root of 121 a squared b to the 4th. All right, try both of those. And I'm going to pause each time. All right, I don't know if you're done yet or not. Oh, it ended up there. All right, so the first one is negative 4. And the second one is also, and the second one, this is a 2, by the way. 2, 2, 2, 2. Negative 2 times 2 is a negative 4. And number 2 is 11ab squared. So again, if I don't ask you to worry about absolute value, then don't worry about absolute value. When I say worry about it, worry about it. Can you take the square root or any even root of an odd radicand? No, not without imaginary numbers, right? You can't get a real number answer. But you can take the cube root of an odd radicand, not a problem. Cube root looking for 3s, square root looking for 2s. Any questions on any of those two, Alex?
Odd radicand or negative?
Negative. Did I say odd? Negative. Thank you. Leah?
The absolute value be if you had us put it in?
We're going to do one in a minute, so we'll do one in a minute, and I'll review that for you. Any other questions on those? Okay, so let's do 5 and 8, and 8 does say to worry about absolute value. Here, I'll just put the numbers that they are, this way you don't get confused. So let's do 5 and let's do 8. And Jeff, 8 is the one where they want you to worry about absolute value. 5 wouldn't matter anyhow because it's an odd index. But the first one ends up being negative. Whenever you take an odd root of a negative radicand, you'll always get a negative out. And so it's a negative 2 out. Cube root of x to the 5th. Would you get an x out, leave an x squared in? So it should have been negative 2x times the cube root of 9x squared. Don't forget your indexes when you finish off a problem. I'm nice, I only make that a minor deduction, but technically you're wrong if you don't include the index. And then the second one, you get a 6 out. You end up with the absolute value of A and the absolute value of B. You should just include them as one absolute value. And then C squared, and you got a 5 and an A and a C left in. Questions about 5 or 8. And again, on the test tomorrow, if I want you to worry about absolute value, I'll tell you include absolute value, okay? You won't get much of them, but I do need to know if you know what to do with them. Any questions on 5 or 8s? Anybody? 5 or... How many got both correct? All right, and I guess you know what you're doing wrong if you didn't, because that's a lot of you. All right, let's go on to the next ones. Let's do 10 and 12. 10 and 12. So 10, Jeff says convert to exponential form, and 12 says convert to radical form. And 12, you should look at 12 and try to make 12 as simplified as possible. So 10 is going in exponent form, 12 is going into radical form. 10 exponent, 12 the radical. All right, hopefully you are, oh, did it again? Thinking I was frozen. I keep pausing and not freezing. All right, so 7 to the 1/2, x to the 1/2, y to the 5/2. That one's pretty straightforward. Put the index there to show you the 2. Hey, on 12, 2 to the 4/3 is 2 times 2 to the 1/3. This way, then, you don't end up with a gigantic radicand. So if you didn't do that, you would end up with 2 to the 4th inside, which is true, which is what, 16 inside? 16a? No, actually 8, 2 to the 8th inside, which is going to be 3264, 128? 256 more. Right, and again, you can see that's a lot less simplified than what we have there. So, let's suppose even if you had no 2 out front, you had 256a. If you count that as correct, how many got both of those correct? Okay, still then. All right, I hope you're taking note of the things that are giving you issue, because these are all just preliminary things. Anything I can explain more on that? Anybody? Anybody want further explanation? Okay, let's roll on. Let's do 23. 23. All right, hopefully you can read my chicken scratch, Jeff. You're just simplifying that. So either way, the left is actually the better answer, but some of you may have thought, well, I'm going to go ahead and factor out that common or the coefficient. Really, the left is the answer. So how many got that correct? Okay. You're just simplifying, looking to then add up like radicals. Like radicals are just like terms. Same index, same radicand. But what ended up happening at the end is you really can't add these coefficients. So even though the radicals are the same, you can't add the coefficients, and therefore you can't add them anyhow. Unless you want to try to apply the rule, which again, this isn't really any more simplified. And this is technically the answer. Questions on that one? Anybody? All right, try 25. Okay, if you got an answer on 3, give me your answer. 1, 2, 3. Okay, I heard what seemed like the correct answer. 7 of them minus 4 of them leaves you 3 of them, right? And x to the a times x to the b equals x to the a plus b. And you just put the variable in front instead of 1 plus x, x plus 1. How many got that correct? And the rest of you see that was not supposed to be a hard problem. You're just applying principles you know, adding up like terms. Go ahead and apply the like base exponent rule, and away you go. All right, let's do, what's next? Let's do number 30. So you get x plus the square root of 5 times 2x minus the square root of 5. All right, you're just simplifying that. Just simplifying that. And you know what, while you're at it, why don't you do 32, which is the square root of 3 over the square root of 18. You're just multiplying two binomials. You got a radical to play with in the midst. Just be careful. This second one, if you really understand the radical rules, then you'll understand that you can make this one radical with a 3 on the top and an 18 on the bottom, which means the 3 and the 18 can reduce, right? Which would be the exact same thing as that. It just saves you time if you notice that, and then you can finish off by rationalizing the denominator. And so where does this thing end up with? Square root of 6 over 6. Okay. Any questions on either of those two? Any question on either of those two? If you didn't do it that way, you could have actually simplified the square root of 18 into 3 times the square root of 2, rationalize with the square root of 2 over square root of 2, and you'll end up in the exact same place. But again, simplifying first saves you time. Okay, do 35, and then I'm going to give you one as well. So that's 4 plus 3i over 1 minus 2i. And my problem is the cube root of 10 over 2 times the cube root of 9a squared. All right, try those two. All right, so left one, rationalize the denominator by the conjugate. Bottom should be a 5. Top should end up 10 plus 5i. Think it's imaginary, a plus bi form. These happen to reduce, so you get 2 plus I. How many got that one correct? Okay, did I make a mistake? So let's see, let me check. 1, definitely minus 4i squared. Positive form, 1 is 5. That one's good. Let me check my top. 1 plus 8. Oh, that's an 8. If I could read my writing, it would be better. That is actually an 8 there. 8 and 3 is 11. All right, so this is 11i. So this is 11 fifths i. So 2 plus 11 fifths i. Did I not read my writing again?
Yeah, the 6 times, or the 6i squared should be a negative 6.
3, 6. I squared is a negative 6. Oh, man, too fast. All right, so negative 6 and 2, negative 2. Much better. All right. Right, negative 6 and 4. So, yeah, that's a negative 6, I agree. That's a 4. That's a negative 2. So that's a negative 2 fifths plus 11 fifths i. Does that sound better? Yay. How many got that right? Much better. Awesome. All right, and then the second one. If you have cube roots, if you'll look for factors that are repeated, it will save you some time in rationalizing the denominator and will also save you simplification. So if you just blindly do 9 squared a on the bottom, then you're going to be able to simplify what you got. You should still end up with the same answer, but you may not see that, and you'll end up unsimplified. All right? Any questions on that last one? How many got the last one correct? Wow, and that was an easy problem. Man, that I'm just telling you, that's easy. You need 3 in the denominator. It's a cube root. That's all there is to it. You need 3 of them. All right. Let's try... Let's try 38. Let's do 38. That many of you are done because your answer is? Okay, this thing's extraneous. As soon as you move the 5, you get a negative 1. When you go to square, you got, how in the world are you going to get the square root of x to be a negative 1? And you can't. Now look, the math will give you an answer. The math is going to tell you 1, but square root of 1 is 1, and 1 and 5 is 6, and 6 doesn't equal 4. And if you went that far and didn't catch it initially, you should have still come up with the conclusion that it was extraneous. Either way, you should end up extraneous. All right, how about 39? We had a homework problem similar to this. All right, for time's sake, if you know what you're doing, then you've already factored out the common y. And if you didn't do that, you're not going to get the problem. Because the variable's not in the radicand. That's the difference in this problem. Now you're just going to move that. Now you're going to rationalize the denominator. And I'm not going to finish it for time's sake because we can do a few more problems. So we just did a problem where we rationalized the denominator. And then you'd finish it off. Okay, we had a homework problem like that. You factored out the common y is really the key to that problem. All right, how about 42? Now you do have the variable in the radicand. What are you going to do with that? Okay, this one's already in the best form, the square both sides. But again, you got to be careful because now that means you're really like that, right? Square root of x times square root of x is x. This is a negative square root of x. Going fast, so help me out. Is a negative square root of x. And negative 1 times negative 1 is a positive 1. Right side is x minus 7. Okay, the x's are gone. Negative 2 times the square root of x. Move the 1 to the other side. Negative 8. Divide it by negative 2. Square root of x is 4. X is 16. Go back and see if that's viable. Square root of 16 is 4. 4 minus 1 is 3. 16 minus 7 is 9. Square root of 9 is 3. 3 equals 3. 16 is viable. How many got that correct? Okay. That one was nice because it was already on the right side. You didn't have to move anything. But remember, like the homework problem or the one on the quiz, you had to move something first before you square both sides. That'll happen. Can you end up quadratic with these? You can. So none of the review ones ended up quadratic that we did. There are, let's see, 44 is quadratic. That's the only one of their review ones, but it is possible to end up quadratic here. I didn't review any of the graphing ones, but definitely review that. It was on the quiz. I would know both your quizzes, definitely all the material on your quizzes. I would definitely be reviewing my notes. And as I've already said, don't forget the front page. And then the other couple things I said to focus on.